Hi, my name is Amit Patel and I'm a design engineer for power products at Linear Technology. Today I'm going to talk about the LT3090, the first in our next generation of highly versatile negative regulators built to address modern power supply design challenges, while still maintaining, as shown in this demo board, the simplicity expected from a linear regulator. The LT3090 employs a current reference-based architecture where a 50 microamp current source flowing through a resistor between set and ground generates a reference voltage. A precision voltage follower in turn buffers this to the output while supplying up to 600 milliamps. While simple to use, the LT3090 incorporates a number of features including a wide -1.5 volts to -36 volt input voltage range, wide output voltage range, programmable current limit, bidirectional shutdown, and positive/negative current monitoring. For negative current monitoring, with I-Mon-P tied to the input voltage, I-Mon-N sinks current proportional to the output current, and connecting a resistor from I-Mon-N to ground generates a negative voltage corresponding to output current. For positive current monitoring, with I-Mon-N tied to a positive voltage, I-Mon-P sources current proportional to the output current, and connecting a resistor from I-Mon-P to ground generates a positive voltage corresponding to output current. The LT3090's current reference-based architecture provides capabilities not available in conventional voltage reference-based regulators, one of which is the regulator always operates with unity gain. As a result, noise, PSRR, bandwidth/transient response, and load regulation are virtually independent of output voltage. This also allows easy paralleling of multiple regulators. Another benefit is its reel-to-reel output voltage capability spanning 0 volts to input voltage minus dropout without requiring a separate supply. Lastly, it supports the ability to bias ground pin to voltages other than system ground. This opens up new applications, as will be discussed shortly. In non-point-of-load regulator applications, where long wires between the regulator and the load degrade the voltage accuracy at the load, the LT3090 is capable of correcting this error via its I-Mon-N pin. As shown here, the I-Mon-N pin sinks a current proportional to the load current, 1 to 1000. Connecting I-Mon-N to a fraction of the set resistor that is 1000 times greater than the cable resistance modulates the set voltage and thus output voltage in direct proportion to the voltage drop across the cable. Therefore, the voltage at the load remains constant. Paralleling multiple devices for higher output current or spreading heat across the PCB is another application simplified by the LT3090 architecture. Moreover, output noise decreases with the square root of the number of devices in parallel. Paralleling conventional voltage reference-based linear regulators require additional op-amp circuitry, whereas multiple LT3090s can be directly paralleled using just ballast resistors. Tying all the set pins together and all the out pins through 20 milliohm ballast resistors guarantee better than 80% current sharing at full load. Given its small size, the ballast resistors can be implemented using free PCB trace resistance. Applications unable to tolerate small load regulation error incurred with ballast resistors can be re-optimized using cable drop compensation previously discussed. Refer to the LT3090 datasheet for details and alternate paralleling methods. Ground pin flexibility is another LT3090 advantage. Unlike conventional regulators, the LT3090's ground pin does not necessarily need to be tied to the system ground. Tying the ground pin to out configures the LT3090 as a 3-terminal floating regulator, and with proper protection, the regulator now supports arbitrarily high common mode voltage applications. For applications requiring output voltages below -1.5 volts, the -1.9 volt minimum input voltage becomes the determining factor in setting dropout voltage, which can be much higher than the typical 300 millivolt dropout. Nonetheless, tying ground pin to a positive voltage at least 1.9 volts above the input allows Vin to decrease below -1.9 volts, thereby permitting low dropout operation for very low output voltages. In conclusion, the LT3090 is a highly versatile regulator suitable for a wide variety of applications. Its unique architecture allows reel-to-reel output capability, ground pin flexibility, as well as all of the benefits from always operating in unity gain. With features such as current monitoring, programmable current limit, and bidirectional shutdown, the LT3090 simplifies your power supply design challenges. Please visit linear.com for more information. Thank you for watching.